Continuing on to page 42, we're going to use another technique to solve quadratic equations, but they're in this special form where they have a binomial that's squared and that equals something. So from dealing with radicals, you might say, well, what do I do to solve this? Well, you're going to take the square root of this side, and then let me write it over here. This way we have a little more room. So the rule is, if you want to get what this is, you take the square root of this side, and that will just give you the radicand. Now, also in our lessons we said when we take the square root of this side, we have to go plus or minus the square root of what's there, so that we're sure to get both of the roots. So this gives us then plus or minus 9, since this is a perfect square. Then we just take our negative 7, transpose it to this side as a positive 7. So then we get x equals 7 plus 9, which is 16, and 7 minus 9, which is a negative 2. Now again, this pattern is unique, where we have a binomial that's squared, and it equals something. So we're going to take, again, the square root of this side, and again, the index number is 2, and that's 2. So we're just dividing this 2 by 2, and it just becomes the radicand. X minus 20 equals plus or minus the square root of 18. But we know from a previous lesson, the square root of 18 is the square root of 9 times the square root of 2. So this is going to end up plus or minus 3, which is the square root of 9, plus the times the square root of 2. Now we then take our negative 20, transpose it to this side, where it becomes a positive 20, and there are our two answers. So x equals this. Continuing with this pattern, we're going to take the square root of this side, plus or minus the square root of that side. This just becomes the radicand, x minus 9, equals, now plus or minus, this is the square root of 25 times the square root of 3. Square root of 25 is 5, the square root of 3. And now we just transpose the negative 9. On this side it becomes a positive 9. And we have then x equals 9 plus or minus 5, the square root of 3. Again, if it's in this pattern, a binomial that's squared equal to something, we take the square root of this side. This will just become the radicand. And then plus or minus the square root of 2. Now in this case, we're going to transpose the 7 as a, got to put my radical sign there, a negative 7. And then we're going to divide by, let me erase that. We're going to divide both sides by 6, and we get x equals negative 7 plus or minus the square root of 2 all over 6. So again, a good technique once we get it into this form. Let's do one more. So we're going to take the square root of this side and then plus or minus the square root of that side. So this is 7x minus 4. Now the square root of 48 is the square root of 16 times 3. The square root of 16 is 4. The square root of 3. Transpose this negative 4 on this side, becomes a positive 4. And now we just divide both sides by 7. And we get x equals 4 plus or minus the square root of 4, the square root of 3, divided by 7. Okay, again, it's an easy topic to solve, or easy example to solve, when it's in this form. In some courses, and we may be doing it later, we will take an equation to put it in this form. That process is called completing the square, but I don't see it here right now. Now on page 43, we're going to take a look at what is called the quadratic formula, and this is the standard form of the quadratic equation. If we go through the process of completing the square and we solve for the letter x here, it ends up looking like this. This is the quadratic formula. And up over here I should have a link in which I actually go through the stages of solving this. I thought that was kind of fun. I hadn't done that in a while, and I had the urge one day and I did it, and I think it works out pretty well. We're going to be using the quadratic formula for all of these examples here, and while it's there we'll do the first one. And in the first one we're wondering, what is our A term, what is our B term, and what is our C term? We need this A, this B, and this C to substitute into the quadratic formula, because that's the values we had. So we look at this equation here, and we see here A is a 2. Now, we don't have a number there, but when there is none, we put a 1 there. B is a -1. And C is a -1. So let's take a moment, and into the quadratic formula we're going to substitute these values. So it should look something like that. Now notice, since there's a negative in the quadratic formula, when B itself is negative, it ends up then the opposite of a negative makes it a positive. So this part is just 1, plus or minus. Now this is going to be -8 times a -1 makes this a positive 8. 8 plus 1 is 9. And the square root of 9 is 3. And this will be over 4. A is 2. 2 times 2 is 4. So we then get 1 plus 3 is 4 over 4. And that is equal to 1. This is a semicolon here. And then 1 minus 3 is a -2 over 4, which equals a -1/2. So our solutions for this is a 1 and a negative 1/2. Now, an interesting thing, whenever we use the quadratic formula and we end up with solutions like this, this indicates that our original equation could have been factored. Let's just check that out here. So this is 2x, this is an x, this is a 1 and a 1. We need a negative 1 in the middle, so this will be a negative and this will be a positive. And if we equal each of these to 0, here this is a negative 1/2. Transpose the 1, divide by 2. Here we just transpose the 1. X is going to be a 1. Okay, so we have in our repertoire for solving quadratic equations factoring, and now we have a new tool, plus the one we just had in which we have it in a binomial form, the quadratic equation. Okay. Now, as we look at this, it didn't have equals 0. I think that was inadvertently left off. If we divide everything by 2, which we can do here, we get m squared minus m minus 6 equals 0. So this is a little easier to work. Our a is 1, our b is a negative 1, and our c is negative 6. So let's substitute it into our quadratic formula. So here we have a negative 4 times a negative 6 is a positive 24, plus 1 is 5. The square root of 25 is 5, so this is going to be 1 plus or minus 5 over 2. So 1 plus 5 is 6. 6 divided by 2 is 3. And 1 minus 5 is a negative 4. Divided by 2 is a negative 2. Again, if our answers come out like this is factorable. And I think we did this one earlier. This is going to be a 3 and a 2. Our 3 needs to be negative, our 2 is positive. So, equal each of these to 0. Here's our negative 2, and there's our 3. Now, as we look at example 3, this is not in standard form. So the first thing we have to do is put it in standard form. 5x squared plus 9x plus 4 equals 0. Okay, so now our a is 5, our b is 9, and our c is 4. Let's put that in the quadratic formula. So, negative 4 times 5 is a negative 20, times 4 is a negative 80. 81 minus 80 is 1. The square root of 1 is 1. So we have negative 9 plus or minus 1, all divided by 10. So, as we look at that, we have a negative 9, and a negative 1 is a negative 10 divided by 10. That's going to be a negative 1. And if we have negative 9 plus 1, that's a negative 8 over 10. That's going to be a negative 8 over 10, which is a negative 4 over 5. Once again, if our answers come out like this is factorable. So we have 5x, x. Now we have to put the 4 there, and a 1 there. Okay. Our middle term is positive, so all of these are going to be positive. Equal each of these to 0. Here this becomes a negative 4 over 5, and this one becomes a negative 1, and we get the same answers. So we have two really good techniques in our pocket here for solving these equations. The quadratic formula is a multi-use one. Now for number 4, is this in standard form? No. We have to transpose that, so this will be a 9n squared plus 4n minus 16 equals 0. And again, it must be in standard form so we can identify our a value, our b value, and our c value. C value is negative 16. So let's substitute that into the quadratic formula. So when I multiply these, I get a positive added to 16. I get 592. Now I have to simplify that 592. So I take it over here and I try to see if I have any perfect square factors in there. Well, I have 2 times 2 times 2 times 2. So that's a 16. It's actually 16 times 34. So this is going to become, and I'll have to use this space down here, a negative 4 plus or minus. Now the square root of 16 is 4. The square root of 34. I should say the square root of 37. Caught myself just in time. Okay, so this is over, and I can divide that into 2 parts actually, like so. This is over 18 here, and this is over 18 here. So I can cancel out. This will be a 2, this will be a 9. This will be a 2, this will be a 9. So now I can put it all over a common denominator. This will be negative 2 plus or minus 2, the square root of 37, all over 9. Yes. And that's the answer they have on the answer sheet. That one was a challenge. So let's go on to our last one here. Again, we've identified A as a 6, B is a negative 2, and C is a negative 9. So let's substitute. Now, when we multiply a negative times a negative, this is going to end up being a positive in here, and it's a positive 216. I add 4 to it, and I get the square root of 220 plus or minus, and this is all over 12. Now, can I take out a perfect square out of there? Well, I go 220 divided by 2, and I get 110. Divide that by 2, and I get 55. So I get 4 times 55. So the square root of 4 is 2. So I get 2 plus or minus, the square root of 4 is 2, the square root of 55. And I'm going to put each of these over 12. So here, this is going to be a 1, this is a 6, this is a 1, this is a 6. So my final answer here is 1 plus or minus the square root of 55 over 6. And I have to just clean that up a little bit. Okay, so not too bad, but again, you need some of the techniques we worked on previously. Now we are at 20 minutes, but this next one is a tad easy. So we will almost let you work on these yourself. Let me give you the parameters once again. We said that what is under the radical sign is called the discriminant. Not including the radical sign, just what's under it. This is the discriminant. So we'll take that off. Now, since in front of this there is a plus or minus this, if this is a value, if the discriminant is greater than 0, let me write it this way. If the discriminant is greater than 0, then you're going to get 2 real answers. If the discriminant is 0 itself, then you're going to get plus or minus 0. You're only going to get 1 real answer. And if, when you work this discriminant, it's less than 0, that is a negative number, then you're going to get no real solutions. So this is what they're asking here. When you do the discriminant, and all you have to do is substitute, b squared is going to be 81 minus 4a, which is 5, and then c, which is a negative 24. Do you get a positive under the radical sign? And in this case, we do. It's 561 when we do this calculation. So there's going to be 2 real solutions. Now when you do 2, 3, 4, and 5, and we'll let you work on those, what do you get? So for 2, under the radical sign, you get a negative value. So that is, there'll be no real solutions. In number 3, when you did it, you got a negative 143 under the radical sign. Your discriminant was this. If the discriminant is negative, there's no real solution. Now for number 4, you had to put this in standard form so you can identify your A, your B, and your C. Once you did that, interestingly, this comes out to be 0. If your discriminant is 0, we said, then there's only one real solution. Now here we had to distribute, transpose that, and we end up with our discriminant ending up being a negative 84. Again, if it's less than 0, then there are no real solutions. Okay, we kept this one a little long, under 25 minutes, but hopefully lots of stuff.